Okay, Bismillahirrahmanirrahim. My name is Muzakkir. I'm going to present about my research on investigation of PID controller design for a water tank system using conventional and particle swarm optimization to limited. Water tank is a container used to store and provide fresh water in many applications. Water tank system provide the perimeter control in water tank system, which is suitable for its application purpose. In this project, the experimental testing of water tank system focus only on the water temperature control system. This is an example of water tank. We have electrical heater, electrical box to control, motor to control the stirrer, so that the water in the container can keep in its equilibrium form. Water temperature control is crucial for some applications such as demineralized water processed in agriculture and oil industry to maintain the product quality. For other applications, time temperature control might not be much important, but it can affect users' comfort. Poor water temperature control can drive to the inefficiency of the operational and energy consumption. Problem statement. It is difficult to tune the PID controller that meets the set point of temperature setting in the BTS. The traditional and conventional method of tuning PID controller cannot optimize the transient response of the system. Operating the BTS with inefficient operational will resulting the waste of energy and affecting the quality of the product. Objective is to design a PID controller parameter using water tank system, using conventional tuning methods to implement a PSO with two different types of objective function, and lastly to verify the best optimal value of PID controller parameter by analyzing optimal convergence curve. Scope first, PID controller is tuned using conventional method, which is auto-tune, Ziegler-Nichols, and Kronecker using MATLAB software. And then PSO is applied to tune PID control parameter with two different types of objective function. And the best performance response is determined by the evaluating the rise time, settling time, and percentage of overshoot and undershoot. This project is inspired from the previous research as shown above. The transfer function obtained in the previous research is used to design the PID controller, and based on the researchers, the best output performance of WTS is when the system can give fast response and minimum overshoot value. Okay, this is some information of conventional tuning method. Auto-tune is the easiest method where we need to just use PID auto-tune block in MATLAB and it will automatically find the value of Kp, Ki, and Kd. Ziegler-Nichols is the most popular PID controller method, but it's not optimal for all application, especially in non-linear system. While Kronecker is suitable for the performance that requires part adjustment such as water tank system. Tuning PID controller for a couple tank system. In this research, the researchers use conventional tuning method to tune PID, such as try and error, auto-tune, Ziegler-Nichols, and Kronecker. And the result is Kronecker is considered the best tuning method because it shows the fastest transient response but produce high overshoot. And the researchers state that the output performance can be optimized by using PSO. So that's why I use PSO in my project. Tuning PID controller for a couple tank system. In this paper, researchers use conventional tuning method to tune PID controller, which is try and error, auto-tune, nickel and Cohen-Kun. Cohen-Kun is considered to be the best tuning method because it shows the fastest transfer response, but for this high overshoot. The researchers state that the output performance can be optimized by using PSO. So that's why I use PSO for my project. Alright. Particular PSO is expected to show better performance compared to conventional method because it can evaluate, it can find the optimum value of Kp, Ki, and Kd based on the transfer function. Alright. This is different between conventional and PSO. So conventional typically does not provide good tuning, and most of the time it has tendency to create an enormous large overshoot, while PSO featured by huge capacity of addressing continuous non-linear optimization problem, shorter calculation and simulation time. The project flow chart shows the overall methodology of the project. After literature review, we need to simulate the open loop uh, of each of Ziegler-Nichols and Cohen-Cohn to evaluate the system S-shaped response to find Kp, Ki, and Kd for each conventional method. After we obtain the PID parameter, we simulate it in MATLAB, and the result is compared to choose the best performance response between conventional method. And then the best result is used as a benchmark to develop a PSO algorithm with some absolute error and some square error objective function. After 20 tests running for each objective function, the best result for both objective function is selected, and then we need to do the comparison and evaluate the performance response for all methods to find the best performance response. Result and discussion. Alright, this is the result after tuning PID using auto tune method. It shows that the rust time, settling time, overshoot and undershoot. Overshoot is sangat besar, iaitu 10.63, dan dia ada undershoot yang sepatutnya tak elok lah kalau kita nak kawal temperature ni. Macam tu. Okay, the second one is Ziegler-Nichols PID controller. We show less overshoot value with zero undershoot. While Cohen-Cohn obtained with shorter settling time but higher overshoot value compared to Ziegler-Nichols. Tuning PID using PSO with some absolute error objective function, we got the response with small overshoot, which is 1.0102%, and the response time is fast, but not as fast as PSO with some square error, because some square error is more fast than is faster, not more fast, it's faster than uh, SAE with smaller overshoot percentage. Alright, this is the parameter obtained, and this is the comparison performance response of all the tuning method used in this project. It shows that um, between conventional method, Cohen-Kun, I'm sorry, the red one is Ziegler-Nico, not Cohen-Kun. The blue one is Cohen-Kun. Cohen-Kun show the faster performance, but it has large value of overshoot, and while this is the convergence curve between SAE and SSE. Based on the convergence curve obtained, PSO with SSE objective function have the better fitness, which 1.1, while SAE is 1.35. This is the information of transient response, or the tuning method. It shows that Cohen-Kun is the fastest response, with only take 0.0606 seconds to achieve rest time, but it have largest overshoot, where based on the result obtained, it is clearly that PSO tuning method with SSE objective function is the better performance of in terms of rest time, settling time, overshoot and undershoot. Conclusion, water tank system is the temperature control system that needs a fast adjustment in order to keep operating efficiently. Among the conventional method, Cohen-Kun shows the better result that give the fastest performance of uh, faster performance but high overshoot. Then comes the PSO tuning method that optimize the PID controller to get the optimum result. SSE objective function give better performance compared to other method in terms of rest time, settling time, overshoot and undershoot percentage. And also convergent curve evaluation. Okay, that's all for me. Thank you. For Q&S question, please contact me with the information provided. Okay, thank you. Assalamualaikum.